Hi, kids. Okay. Hey, we're gonna do a double slit problem here. So I have 500 nanometer light. So that's probably, I don't know if I had to guess, probably something like bluish light, maybe greenish light. Because remember, light falls between 700 nanometers to 400 nanometers. So we're towards the 400 side. So higher frequency light. It goes through two slits, creates an interference pattern on a wall. The wall is 4 meters away. Each bright spot is 20 centimeters apart. And then we want to determine what is that slit separation. So, as always, if you are faced with any problem in physics, where do you start? Well, you start with the picture, so let's sketch out our picture. So, we can do this, I don't really care how if you do it this way or this way, but I'll go this way. So, we're going to say, all right, I have here are my two slits. Okay, they're going to be separated by a distance d. So that is what I'm looking for, that unknown distance d. I have my wall down here, and the distance from there to there is given as 4 meters. And then I have my bright spots down here. And since I'm guessing it's blue, we'll maybe use blue. But my first bright spot is going to be right in the middle. Okay, that's where my path difference would be 0. And then I'm not going to draw this to scale. I'm going to draw it so we can see it. So the first one, which remember we typically call y1, is going to be there. And then y2 and so on. So that if I was to set this up, and let's say, for example, I'm going to go to y2. It doesn't really matter. And then same thing on the other side. This is my 0th maximum, first maximum, second maximum, first maximum, y1, second maximum, where the distance from here to here is 20 centimeters. Okay. Then if I sketch out the light, what the light is doing. So the light is, let's say I'm going to go to here, that I have my two path lengths. One is going to look like this, and then one is going to look like this. Remember, the whole key to this is figuring out what is the difference in path lengths. So if I was to say, all right, here's a right angle, this right there is going to be my difference in path length. So that would be my delta L, okay, the difference in path length. Does that make sense? This little piece, okay? So hopefully that makes sense. So then if you're like, all right, so I sketched out my picture. Oh, I guess I'm going to y1. I think I said I was going to y2, but the way I drew it, I'm going to y1, that's totally fine. But if I was to sketch out my picture, and if I was going to do this, I'm going to work it out from scratch just so you guys can see, because again, I don't want you guys to memorize. It's understand and apply. But if I was to set this up, I would set it up like this. I would say, all right, so if I call this, slit 1, slit 2, the length for 1, okay, it is going to be L1, and this would be L2. So that means my path difference, which is this little piece, is going to be L2 minus L1 equals change in this. Okay, I can see that from my picture, no problem. And then if you say, all right, so this path difference, if it's going to a bright spot, you have to figure out your starting condition and your ending condition. So because I'm starting with the same light and it's going through two slits, that means I am starting in phase. So if I was to sketch a picture, this is my starting condition in phase, IP for in phase. And then if I am going to a bright spot, that means I am ending in phase because it's bright. Okay? So if this is my starting condition, this is my ending condition, that means my path difference has to be a multiple of the wavelength. Okay? So, hang on. Now you can see it. Sorry, there's a little bit of glare. But it should be a multiple of the wavelength. See? There you go. So it'd be a multiple of the wavelength. That means that this has to be m times my wavelength. Because I'm going to my first bright spot, my m would here be 1, Okay, if I was going to my second bright spot, my M would be 2, and so on. So my delta L in this case is going to be 1 times the wavelength, okay, which is going to be 500 times 10 to the minus 9th meters. So let's change everything to meters just so we are going to be consistent, okay? Then you have to go, all right, if that's the case, I need to figure out what this little angle is going to be. So if I want to figure out what that little angle is going to be, that as long as I'm far enough away, which I am, that if I draw out a right triangle here, so I'll draw it in red so you can see, here is a right triangle. This angle and this angle are going to be roughly the same. If I call this theta, that it would be theta. So this piece here, okay, is going to be, if I was going to solve for it, it would be tangent theta, okay, equals opposite TOA over adjacent. So it would be y1 over the length, which is 4 meters. So if I do some math here, this is 20 centimeters, so 0.2 over 4. And if I solve for my theta, I get, let me do it. 0.2 divided by 4 equals second tan of my answer. And I get 2.9 degrees. 2.9 degrees. Hopefully that makes sense. And then because 2.9 degrees is going to be roughly the same, so but if I do, since this angle and this angle are going to be essentially the same, I can set this up so delta L equals M this, D equals D sine theta equals M this. If you guys look, these two formulas are on your formula sheet. Here, hang on. Let me do the lights. Can you still see? I don't know if that made it better or not. Well, sorry. There's still a little bit of a glare. But let me block the glare. All right, there you go. Okay, sorry. But if I plug my numbers in then, so if I plug my numbers in, I'll do it, I'll erase and I'll do it up top, just so you guys can see. I'm going to plug my numbers. I'm going to have M, I'm going to have D sine theta equals M this. D is what I'm looking for, sine 2.9 degrees equals 1 times 500 times 10 to the minus 9th. And then solve that for D. Sine of my answer. And I am going to get 500 e to the minus 9 divided by that. I'm going to get a really small answer, which is 1. Essentially 100 times 10 to the minus 5th meters. Okay, which would be roughly, okay, it's going to be roughly about 10 micrometers. Okay, so it means my two slits are 10 millionths of an inch, or sorry, 10 millionth of a meter apart. Hopefully that helps. Bye, kids!